Today I want to talk to you a little bit about Golang keywords. So you can kind of think of the keywords as the pieces that make up the language itself. And so we have a really great article here on Medium by Santosh. Hopefully I'm pronouncing that correctly. If not, you can correct me. Um, that he really just broke it down into four different groups for these keywords. And so something that's really interesting about Golang is it's actually some of the um, as far as the language goes, it has some of the fewest keywords of any language. And so I actually really like that about the language. It keeps things concise. It keeps things very clear and simplistic. And I think it's important that a language is that. It's often difficult. I often think of PHP mostly because it's where I cut my teeth on a lot of programming, but like array management and all these different things. There was all these different functions that were kind of built into PHP, and although they're not technically like the keywords of um, of the language, it's I still just kind of go back to that where oh well, if you're talking about this array function, the parameters are this and that, and then this other one does the same thing, but the parameters are switched, and just little things like that. And so it's so important for a programming language to be very concise. All right, so let's dive into this. What are the four groups? We have declaration, composite types, control flow, and function modifier. All right, so let's dive into declaration. So we have const. This is for a constant for any scalar value. You can think of a constant as a constant value. I don't know how to explain it better than that, but essentially the idea is that you declare it and the value cannot change. That's the important part about it, right? So something to know inside of Golang is if your variable name is capitalized, it will be exported, which means that other packages can use it. So it's important to keep in mind if you want your constant or any variable or anything else to be exported and used by other packages, make sure that first letter is capitalized. Also, if you use like linting and formatting, they'll also want you to add a comment. The proper way of having an exported variable or constant or function or type or any of those sort of things that we're going to talk about here is to both have a comment and for it to be capitalized. All right, so next, variable. If you've not been in a programming language before, often what you need to be able to do is to create something that temporarily has a value, and often you want that value to be able to be changed. So that is when you can use the var keyword, is when you want a particular variable to be able to change. Something that's important with Golang is it is a statically typed language, which means that once you declare a variable to be a certain value, or sorry, a certain type, then it has to stay that type throughout, and Go will actually give you a build error if you try to, or a compile time error if you try to do something different with that. Obviously, like everything, there's little hacks around that. Don't use them, simply put. But yeah, so func, keyword for declaring a function. So functions are where you do some level of processing, right? And you can have functions that are standalone, where maybe they take some parameters and give some outputs, or they can be attached to a particular type, which actually makes that a method, but you still use the func keyword to declare that. All right, so type. This is a really generic kind of thing, but yeah, it's just a keyword to declare new struct types. struct is one, I guess, type, but yeah, I don't know if I have a real great explanation for that. That's kind of one that you just use and you see it, and maybe it'll make more sense. So when we get into the coding side of that, we'll dive in. All right, so the import keyword. This is for when you want to include or import other packages. So we'll obviously see that when we get to the coding part here as well. All right, and package. This is where you can group your code into units, and those units are called packages. You can use the package keyword. And there's some like special ones like main that have a special use case, basically declaring that it's kind of the entry point of your code. So just keep that in mind as we kind of go through the code and stuff like that. All right, composite types. So this is where there's like multiple pieces to it, right? So Go has something called channels, and you can kind of there's lots of great explanations for that. I don't want to dive too deep into that here, but you can kind of think of it just a way of passing messages, and this is really important. I use the word parallel here, but really the importance of this is in concurrency as well. So when you're trying to build something that can be concurrent, which is the only way to be able to build something that then can run in parallel. So just keep that in mind. Channels are a great way to pass messages back and forth in between different pieces of your code. All right, an interface. So this is kind of interesting. You can define an interface. Something that's interesting and maybe a little bit different than languages that you come from. If you're from Java or maybe PHP or pretty much any of them, they almost always tell once you declare an interface, when you want to use it, you have to use some other keyword like implements. This class implements this interface, and by doing that, that's when the compiler or if it's a scripting language, the interpreter knows that you're trying to use that interface. Something that's really interesting and very different about Golang is that when you declare some interface, if some type implements everything that interface defines, then it actually automatically implements that. And so you can use if you have you've defined some interface. It's supposed to have this function on it with these parameters passed in, and this return value. If you use that, or you put that function on some sort of type, then you can actually declare that something can use that interface. That type will automatically be able to be passed in for that interface. So it does that all implicitly. Really cool. Probably one of the best features, I think, about Golang. All right, so map keyword. So unordered collection of key values. So that's pretty straightforward if you've done any programming before. Yeah, not too much more to say about that. Just know that these things can kind of be intertwined with each other. You can have a type that has one of its values be a map, or one of its properties, I guess maybe you'd want to call it, be a map, or another one be a struct, or you can have a struct inside of a struct. So that's really why he's called it composite types, because you can combine these things together to make something that's larger than itself. All right, so let's dive into control flow. So these are the keywords that kind of decide the flow of the code. So let's just dive right into here. I did not put these in a great order, but all right. So I think they're in alphabetical order because that's what the top list was in. But so break, if you're inside of a loop, the only types of loops that exist in Golang are for loops. you can set them up to kind of be treated like while loops and stuff like that. But yeah, the only keyword that's there is for loops, so important to keep in mind. So this will break out completely outside of the loop and continue execution right after that, right? So case. So inside of the inside of a switch construct, you can, you have your switch, you have the value that's kind of being tested against, and then, or the value that's being handed in, I guess, to test against, and then each case, right? And so let's say that you hand in some string that says hello, then you can have a case of hello, and then your code underneath that. We can see an example of that later. Continue, similar to break, but it only gets you out of that particular iteration, right? So let's say you've started a for loop that's going to run 5 times. If you hit a continue and you're on, let's say, the second run of it, it'll just automatically jump you back up to the beginning of the code of that for loop into the third iteration. So very handy if you get to some point and you're done with, maybe you're checking something while you're looping through, and you need to just, once you find it or once you do whatever, and you just need to get out of that particular iteration of the loop, you can use continue. Default, so this is using specifically the switch statements. This is if it falls all the way through and there is no value, no cases that it accepts, or that match or return true, if you will, then it goes to the default. So then you can, so when no other cases are matched, you can use this control expression to say what it should do by default. Hence the name. Good naming. All right, else keyword. Yeah, this. It'd be nice if we used if maybe first, but all right. So in programming languages, you're going to run into if statements and else statements. If statements being, well, I'll just talk about else here. So if you have an if, you're testing against some parameters. Those are not, and then you want something that happens if that's not true, right? Then you can have an else. So it's essentially, if your ifs or else ifs aren't true, then it's almost kind of like the default value in some ways on a switch statement. It kind of has that same sort of vibe to it, where it's the alternative. It's the it's an alternative to what with if the if is not true, does not return truthy. Okay. Fall through. This is kind of interesting one. Basically, it lets your case or your switch statements run multiple cases. There are probably really good use cases for this, but to be completely honest, I've not hit very many of them when I've programmed with Go. I can see where it could be useful. I've just never had to use that. So be careful. Don't just assume that maybe fall through is your right choice. There might be other options or other kind of ways of programming that maybe fit better, right? So just think it through. If you look up more about fall through, you might find that it's not super useful for you, but nonetheless, it is one of the keywords. All right, I talked about this a little bit earlier. For. So this is for loops. For loops. There you go. Yeah. So this is the way that you can do looping with Golang. We'll have some examples of that. So we'll get to those when we get to the examples. All right. So go to. Don't really use this either. Essentially, you can jump to a particular spot in code by you label a particular area, and then you can say go to in that area. You can kind of think of it as like a break or a continue, but it's kind of way more. It's not within the confines of a for loop. It's wherever you're at in your code. So you could have some if statement, and then the next thing could be, okay, well, if this if statement is true, go to, and you could just go into a totally different spot in your code. Yet again, it's a little bit of a throwback to kind of older types of programming. I don't think that it's super useful in today's world. I understand why they have it in there, but just make sure that you're really, really, really actually needing to use a goto, right? You could write really terrible code and never write a function and just write a bunch of gotos. You don't want to do that. That's not a good idea. That's really, really not a good idea. Functions are, a much better choice if you want to execute a grouping of, logic than using goto. So use sparingly. Really think about it if you really need it. All right, talked about if statements a little bit before. So, yeah, I don't know why I was so specific about checking within a loop. That's not really what I meant to do there, but so an if statement, it just checks if a certain condition is true. So if it is, then it has curly braces, and then it will start executing the code inside of that. All right, the range keyword. So this will allow you to iterate over items like a map or a slice, array. Those words are kind of used. They're not really used interchangeably, but oftentimes that is how we use them. So a map, we talked about that before. That's an unordered grouping or unordered collection. An array in Golang is actually, let me add. Oops. Let's go into editing mode here. Yeah, so over a map, unordered collection, array is grouping a collection, but it has a specific amount, a specific length to it. So you define that when you define the array. A slice does not have that. And essentially, under the hood, it's basically using an array, but it's kind of a variable type array. So you can append things to it, and when it hits whatever the original cap or maximum was, then it will continue to add to that, and it does a lot of magic under the hood to make that happen. So all these things can be ranged over, and we'll see that in the code as well. Return statement. So you're in some function, and you need to return variables back out of that function. We'll see that in the code. Use the return keyword. Select. This is kind of interesting. I won't go too deep into this right now, but just know that it's a keyword that kind of allows you to. It's kind of similar to a switch statement, but it is. Yeah, I don't know if I have a really great example of that in code, so let me just leave that one for a hot second here. But just know that there is a select keyword, and that you can basically wait on simultaneous communication operations, and it will wait on those, and then whichever one kind of comes in first, it will run that. So kind of a neat thing. It's more with concurrency and that sort of stuff. So anytime you see like this communications, right? When I talked about sending messages back and forth for channels. Yeah, so when we're talking concurrency, we often need to communicate sending messages back and forth. So that's what this select statement's all about. Perfect. Okay, and then last one here for this. This is a big section. Switch. Excuse me. Yeah, so we kind of talked about this before. It's basically a way of, instead of using a bunch of if-else or if logic, if you will, it's kind of a way of kind of automatically doing that. You have your switch, the value coming in, and then you have a case statement that can test against that value. So really cool, really useful. I find myself often I get into this mode where I just type a bunch of if statements, and then when I'm going back and refactoring, I'm like, why I should be using a switch statement here. So switches are great. Really great way to have if you have a lot of different cases that you're trying to go against. Don't use if and else ifs. You can use a switch in case. It's really nice for that. All right, function modifiers. Last two here. Okay, so defer. Basically, there is a context around whatever is currently executing. Within a function, you can kind of think of it as like when it returns, that context of that function is gone. Any of the variables that you define or anything that you're doing within that, kind of it gets garbage collected. Because Golang is a garbage collected language. So in this particular case, the defer keyword is a way to basically say, when I go out of this area of execution, run this thing, do this thing then. It's really great for like closing files, right? So you open a file, you can immediately defer closing it. Now you don't have to worry about memory leaks, right? Now down at the bottom, you don't have to like, oh, right before I return, I want to make sure I close up the file, right? We can say defer, and then the moment it does the return, it's also going to close out or run that defer statement, closing out your files. File is just one example. It could be other types of I/O in specific is really where it's useful. You can defer closing connection to a database. You can do that for network calls. There's all sorts of different places where defer works really well. Often the case is when we're working with I/O, input output, right? All right. This is the bread and butter. This is the one of the best keywords in all of Go. The Go keyword. Yeah, so it's for running what they call a Go routine. You can basically think of it as what other languages have for like threads and that sort of stuff, but it is super lightweight. So it is no big deal to have thousands and thousands and thousands of Go routines running, and so this is all about, yet again, concurrency. It's kind of the name of the game here with Golang. So yeah, we'll dive in and see that a little bit. So one of the ways I wanted to show off this, and we'll get into this in the next video, is with Project Euler. Not Bueller. All right, I'll see you in the next video.